Yes, hello, recording officially. Is this good news or bad news that we're almost through all the rows on the schedule?
Yes.
Yes, exactly. I know this is the point in the semester where people start to go a little nuts. Just remind you, this is finite. Okay, one way or another, the semester will end, and all the things that is currently hanging over you will end with it. Then you just have the things that are hanging above that are not semester specific, like dissertations, other ongoing research. Yes, hang in there is what I'm trying to say, and I'm talking to myself too, quite frankly. Let's see. So, despite Erica's best efforts in extending the quiz as instructed, I still managed to get Lecture 5 and Example 5 done for today, but I don't know how much of it we'll go through. So thank you for your help with that. Now I'm prepped for Tuesday, for sure. So that's always a nice feeling to go into the weekend. So we have that. If you haven't already downloaded those files, please do. It's called Example 5 because I was not sure whether I would actually have room to make it 5A and get a 5B, so we'll see. We'll see how it stretches out. Homework 3 is due Monday. How is that going?
Need to check my words.
Okay, have we opened it? Okay. Yes.
Numbers are done.
The numbers are done. Okay. So I know that is a popular strategy to go through and do all the numbers and then go back and do all the drop downs. It's confusing because you really need to pay attention to what is in the current model to answer the questions. Mm-hmm. And so if you didn't just find all the answers to the numbers, it can be harder than it would otherwise be. So just if you're doing it that way, just make sure you're paying attention to the context.
Let me rephrase. Numbers, words are done. I want to review my words.
Okay. Answers are inputted. You're just sitting on it until you feel like it's done enough.
Until it's done.
Until it's done. That's fine. So section 3 is hard, you said. Is there anything you want to ask about?
I was just reading and trying to think about how to do it and read something.
Would it be good to discuss it? Do we want to look at it?
I think it would be useful. I found it challenging also, and a refresher would be good for me.
Okay.
Let me log in. It's supposed to be challenging, to be clear.
Oh, yeah.
Because this is your last chance to do something on canned data where you know what should happen. After this, it's the wild, wild west because I don't know what's supposed to happen in your data, and there's no right answer that you know of either. So it's a question of can you execute on your own? So let's see. Yes, this is designed to be more challenging. That's why it's worth 18 points. So that's a good chunk of your final grade. This is combining what happened in homework 1 and 2 and then adding another layer of complexity. So a lot of the code that you would have already written, you can repurpose for this or edit relatively briefly.
I mention something really quick?
Yes, please.
That would help out. That wonderful note about optimizer. If you're using R, start out with that because I will tell you when I was working with this, I kept getting the error, but I had it set up right and then I put that in, and then I did not have the error. So I hate for people to waste their time like I did, thinking I got it wrong.
And this is just a consequence of slight differences in algorithms,
Exactly.
creating differences in the second decimal place. Mm-hmm. I'm sorry. I don't know how to fix it other than that I played around with this. No, it's a fair complaint. Yeah, so what ends up happening in certain random slopes models in Elmer, but not LME, is that they get off. And that's particularly the case, by the way, for any model that has time and quadratic time. Like those never agree across programs for whatever reason. But this one I have found in practice is not the default optimizer, but this one tends to yield results that are closer to what they are in SAS. And so that's why I said use this. Vladimir and Erica, have you encountered any questions in office hours or otherwise about R not matching? Not yet? Okay. So yes, if you're like, damn it, this model should be right, what is going on? Try that. And also, if you're like, damn it, this should be right, always try plus or minus 0.01 of the answer too, because sometimes that will catch it. So it's an imperfect system. But it's the only way I've figured out thus far to make it so that you can use your program of choice in doing homework. There has to be a little bit of inconsistency across that. So section 1, ICCs, should be straightforward. Section 2 is focusing on how anxiety differs by years of experience between treatment A and B and rural and urban. So if I'm reading that, what is like the translation into code that that sentence would imply? What's in the model at this point?
Years of experience that was centered appropriately.
Yeah, so anxiety is the outcome. These are people nested in hypothetical treatment sites. So years of experience of the site's group leader, that's going to be a level 2 thing. Between treatment A versus B, that's a level 2 thing. And between rural and urban, those are all level 2 things. And the way this is worded is meant to imply additive effects up to this point. This, and this in the model. But then, as in homework 1, allow the effective treatment to differ between rural and urban sites. What's that in code? There we go. Which things are moderated in particular?
Treatment type and site type.
Yep. Is that a cross-level interaction? Nope, just straight level 2. Yep, so that would go in the beta 0 line. Hint, hint, in terms of which variance it would account for. If it goes in the beta 0 line, what's it predicting? Random something. Yeah, intercept, yep. In addition, your model should examine the effect on anxiety of persons' coping skills, centered as such, and the incremental contribution of coping skills for the people of the same site. So this is setting up a particular version of the model in terms of what the coefficients should then mean based on the centering scheme. And then we're adding in one more person-level predictor and its incremental contribution centered at constants. So the fact that these are both centered at constants at level 1 and level 2 should clue you in as to what those effects should mean. There's a one-to-one correspondence there, and you can find it in many slides or in articles in your textbook, what have you. So this is going to walk through all of that. So then I tried to make it less overwhelming by breaking these up into little paragraphs and also keeping like, hey, this is what this paragraph's about in bold. So a little bit of visual demarcation. Section 3 you said is hard. Is that where we're at? Okay.
I haven't finished section 2, the next one.
Okay, fair enough. So as we look through the section 3 questions, estimate a new model that allows site differences, specifically in the within site effect of coping, and specify your model to avoid any fixed or random slope conflation. So site differences specifically in the within site effect of person coping. What is that? What am I talking about? How can the model be changed to allow site differences specifically in a within site effect? Yep, it's random slopes of the within cluster effective coping. And then how do we make sure that that new random slope is not smushed? That's the last part. So there's an extra little step to consider to make sure that that is the case. The keyword to search for in the slides would be hybrid model. That's the idea. From there, I think the rest of this should be fairly straightforward to find on your output once you've tackled the code in terms of like what the words mean as the model. That could be the trickiest part. Last but not least, I think, section 4, yep, that's the end. Keep everything from before, so at every stage we're just adding stuff, not taking it away, and then examine how treatment type moderates the effects of person coping and site mean coping. Those are interactions. Yep, the effects, so that should clue you in that there's more than one interaction to be considered at the same time. And that is it. So it's a little longer, it's more complex. I think the hardest part is just trying to map the terminology to what should be in the model and how to talk about it. But honestly, that's the part that matters the most in practice, is being able to take a research question, translate it into a model component, estimate it, and then talk about it.
Those are the dollars that you can get.
Those are the dollars. The middle part is what ChatGPT can do. right? It can write code and spit out output, but what the numbers mean, it has no idea. So the person element on the back end and the front end is going to be always something that people are willing to pay for. And no offense to the folks in statistics, but they're not always the best at putting it back into regular language again, because that's not an aspect of their training that is often emphasized. Just like I'm not the best at talking about likelihoods and integrals, because that's an aspect of my training that doesn't exist. So, not that I'm proud of that, but that's just a difference in emphasis.
Statements of fact.
These are. Well, I was going to be a psychology major. I didn't need math. There's no math in psychology. Oops. I got all the way to my sophomore year before I realized that that was not the case and started taking research methods and then wished I had more math. But coulda, woulda, shoulda. All right.
Still could.
Yeah, still could. Yeah. Not today. Not today. Any other questions on homework? Does that help at all to try and just sort of orient ourselves? So due Monday. It's only Thursday. Office hours as usual over the next few days. I'll be on email over the weekend for better or worse. If you have questions, don't hesitate to reach out to. I don't expect the TAs to answer email over the weekends, but I'm saying that I will. So it's up to y'all. All right. Then how about we wrap up example 4 for real this time? I mean it. Then we can talk about cross models a little bit. All right, we were in the 4 layer of things here, I think, in this case. So we had added the second predictor that differentiates kids who get reduced price lunch from free lunch. And then we were starting to look at what changed in terms of the solution for that. So I'm adding both main effects of that new predictor in one step. This is model 4A on page 14. We have a new dummy code. It's 001 for paid, reduced, and free at level 1. That level 1 placeholder then gets a fixed slope in a new level 2 equation. So placeholder is a word that I've used for years. I picked up one the last time I taught this class, backpack. Betas are backpacks. And I'm not talking about Dora the Explorer and her friend backpack. I'm talking about a backpack that doesn't have legs and it doesn't contain anything until you put stuff in it. So it's like you are setting up a place to store the fixed and random effects that are going to create this term, but you're not putting anything in them yet until you come to the level 2 equation and start putting in the ingredients. So I don't know if that helps at all. In the connection to latent variables within the world of structural equation modeling, people describe these betas as latent variables, because in that way of thinking about those things, the factor mean is the fixed effect for that variable, and any random effect variance would be the factor variance. So that's another way that you can hear the term latent variable in connection to that context. That's usually in the dimension of longitudinal models rather than clustered for whatever reason, but the analogy breaks down the same way either way. And then we have this one. So this one is the cluster mean of that new binary variable. Is this optional or required? Well, it's a multiple choice question. So by required, I mean the model would be misspecified and incorrect without it. Yeah, and optional means you could keep it in, but if it's 0, you could take it out. Which case is this, required or optional for level 2? We got 1 vote for required. Who else wants to vote? A couple nods? I'm looking till see it. People are nodding or shaking their heads. Okay. People are like, I'm not going to vote. I don't want to be wrong. It is indeed required because this level 1 predictor has not been centered using the cluster mean. That's the thing. So if you create level-specific predictors ahead of time through cluster mean centering, then you're not assuming anything about the level 2 model. Whatever you put in can be 0 or not 0. If you don't cluster mean center, then you by default are assuming that this fixed effect is going to cover both the within effect and the between effect. And that means that the level 2 contextual effect to solve that problem is not optional. So we put it in here. So we have fixed main effects at level 1 for essentially reduced versus free, and the corresponding cluster mean effect at level 2 for the contextual effect. That means that in terms of a model of implied between effect, those are linear combinations. So these two, that's the within effect of paid versus reduced or free lunch for this one. That is within plus contextual. We have the same idea for the between level interaction for that variable, which is the cross level interaction and the level 2 interaction. And then we pick up a between model implied slope that's not simple because there's no interactions yet for the new binary predictor differentiating reduced and free. Okay. Questions up to now? We're good. Okay. Put them in the model. Lots and lots of resource code. So I'm computing changes in pseudo R-square. So what is the pseudo R-square for the new model? And then how much did adding these two terms help it is the question. So I did that in Stata. Got a total R-square for, since that's the model we're going to end up reporting. Same stuff in R in terms of, here is the new interaction term, or not interaction, excuse me, these two new main effect terms. There we go. Let me zoom in a little bit. Note that I moved them to be second to last so that the order would match what happens in the obtained output. My normal approach when I'm adding in fixed effects is to add them to the end of the formula, but in this case it would have rearranged them, so I was like, fine, let's keep it internally consistent. And we started talking towards the end of class about how these things have changed their interpretation. Most of them have. So the intercept is, I think, like the only thing here that hasn't changed its interpretation based on the model. That's because we haven't added any new variables into the equation. We've just differentiated two of the categories within existing variables. So this is still for a child who pays for lunch at a school where 30% of the students get a discount of some kind, and adding in the new fixed effect also at a school where 19% get free lunch. So this brings us to the 11-19 split that we saw in the descriptives way back when. So kids who pay for lunch, they are now 5.8 points higher than kids who get reduced price lunch specifically. So with the new person level variable, R and F are split apart. So you can think of this as like a stepwise function. You have the paid kids shifting down to the reduced, which is a drop of about 5.8, and then the reduced kids further dropping by 4.5 in this case. So that gets us to about the 9-point drop that we saw on average in earlier models where these two things were collapsed together. This main effect of paid versus reduced is conditional on the interaction term down here. So that means that specifically for schools in which 30% of the kids get a reduced price lunch or free lunch. This one is not yet conditional on anything. So that's where like trying to figure out which ones are conditional on what gets a little bit tricky. But the lack of interaction implies that this aspect, this difference, reduced versus free, would hold regardless of what kind of school you go to. At level 2, so this is for the first contrast. For every 10% more kids get a reduction, their score for the school goes down by 2.2. And then this one here further splits out reduced versus free. For every 10% more kids get free, then your score goes down by 0.6. Or up actually, yeah, you're right, it's positive. Unexpected on that one. Non-significant, but unexpected. So you'll notice, like, look at the size of the standard errors here. They're starting to get, like, kind of big because these coefficients are kind of big. So I watch for these things as indicators of model instability when you get to the point where you have a lot of contextual effects and they might be strongly related. In this case, like, this is essentially like the same information being split into two pieces. So you might expect some difficulty in trying to recover that. And then, of course, the degrees of freedom being very different. Can you guess why? Why does our new level 1 contrast have degrees of freedom of like 12,000? And the others have degrees of freedom around 200 or 100? Any guesses?
Number of students that are in the paid and reduced versus the free.
It's not related to sample size per group, because if this were a non-group variable, the same thing would happen. This is a hard question. I'm going to let you chew on it for a minute. Question is, why are these degrees of freedom so different than the rest?
It's non-native sample.
It's not related to the sample size of people who are in the free or reduced group specifically. Like, it's not related to the contents of this variable other than the fact that it's a level 1 predictor. But it is sort of related to sample size in a different dimension. So do you remember the sample sizes for this analysis? How many kids do we have? Like 13,000 and some odd? And like 150 schools, something like that? I'm on page 15. Let me go back up to the top. 13,000 kids from 94 schools. Not quite. I'm going to call on the TAs. Do you have any ideas?
Yeah, I think that's because that's a level 1 variable without anything at level 2.
Bingo.
So that's why the first category for that variable has 208, because we have a random slope for that.
That's right. So the answer is, like, if we just zero in on these two things, the first variable has a random slope that goes with it. So it's treated like a level 2 thing in the model because the fixed slope is the middle of the level 2 distribution that the random slope variance is around. The same is not true for the other level 1 predictor, which is only fixed. So rather than thinking of it as the middle of a distribution, this is just a slope going through all the data without paying attention to which rows are tied to which sites. It's just like one aggregate slope. And it's tested with degrees of freedom that are going to be closer to what the student level degrees of freedom are than the cluster level. But this is degrees of freedom for the denominator estimated with the Satterthwaite method specifically, which is why they look all weird. I never see these reported in manuscripts, by the way. I never see this column. You can just say I use the Satterthwaite method in R, and that's usually enough information. But these things are estimated quantities taking into account the relative variance in the predictor with the relative variance in the outcome and the relative sample sizes. It's a whole thing. Once you get past, like at some point, the critical value for t is not going to change as a function of these things, right? So infinity is somewhere past 30, like this is going to be fine. But in smaller samples, it does make a difference. So what do we conclude about our new effects? Does it matter at the student level if you get reduced or free? Yeah, e to the negative 15. So yeah, it looks like there is a difference between reduced and free at the student level, and it doesn't look like there's much of a contextual effect. So this one is interesting because the typical interpretation of a contextual effect is, here's the effect of school level whatever after controlling for the student version. This is that, but it's also controlling for this one. So it seems like, just eyeballing this pattern here, that there's a contextual effect in moving from the average for paid versus reduced, but then there's not another one to move to free. So it's like there's a big difference as a function of the percent of schools that get discounted lunch, but not necessarily as a function of free versus reduced. That's my impression. That shifting into the second category is where most of the action is. But this is where I had to make pictures to make it figure out. And even though I spent, I don't even know how long, 2 years ago making these pictures, I forgot how I made them. So I spent some time looking back at that. So if you've ever had that experience where you go back to something you've worked on and you're like, I made this? Like, I have no memory of this. Yeah, welcome to my world. And that is why, for those of you who are interested in academia, don't ever buy into the myth of a class that is prepped. Like, you'll hear this expression, oh, this is a new prep. Oh, I have that prepped. Prepped implies that it's done forever, and it will not be. Especially if you teach a class every 2 years, and by the time you get it back out again, there's a new package in R, and the defaults are changed, and oh, now there's research that says this thing you taught for 3 weeks is wrong, and like all that kind of stuff. So I am ready to tell you about the pictures. That was my objective here. Before I tell you about the pictures, I was today years old when I learned a cool Excel trick from Michael. So watch, okay? I'm going to hit Control tilde, and then in my spreadsheet, what is shown is all the formulas instead of the values, so that you can more readily check patterns of things.
Or check yourself if you think that you're a typo.
Yes, and then when you're presenting in front of class, you can zoom in so that folks can see the equations rather than having them stay tiny up in the little bar here. So I thought that was super cool, so thank you for that. I'm going to hit Control tilde to get back out of it for the time being so I can walk through the pieces of this. Now, in terms of a potential workflow for reproducibility, don't do this, okay? This is me trying to make sure I understand things to talk about them. And I did so in a way that I hope will be transparent regardless of what software package you're using. You can see the inputs that create the predicted values, and you can see the equations that they're predicted in. Once you figure out how you want to do this, I would put it inside R or inside Stata so that you're not the one manually copying things down or rearranging equations. There's just too much potential for error there, especially if you have, let's say, 10 different outcomes by 6 different predictors and you need to make 60 plots, right, Vladimir? That's his life this semester. He's making plots he's copying and pasting things. Well, just so you get it figured out for the first one, right? And then you're going to run an algorithm that makes the other 89?
Yes.
Okay, good. Yes. But, so with that giant disclaimer, I just pasted in the fixed effects and pasted them down the row so that the formulas could be dragged down for easiness. When you are then figuring out who you want to show predictions for, in these models, centering is quite complex. So I would recommend starting with just the original variables. These are in gray right here, like as your anchor point, and then write formulas or code to do the centering as you did in your data, because your brain will work much better if you think about it in original values. So for instance here, the intent of the first plot is to show what happens holding constant school proportion of free lunch. So I'm going to show a contrast between the proportion of reduced and paid. And I'm holding free at 10% in each of these lines here. So to do that, I hold the second contrast to 0.1 because that's 10%, so I want all the lines to have that as a base point. But then I have to think about how to vary the other one, because this is the proportion of students who get free or reduced lunch. So then if this is 10% and this is 20, that means that it's evenly split of 0.1 and 0.1 each, because this column is the sum of reduced and free. So I have 20, 30, 40, 50, and then when I subtract the centering point of 0.3, I get this column, which is actually what is going to be used to create the predicted values. So this is my level 2 predictor that indicates the amount of students who get reduced lunch holding free or lunch constant. So it's paid versus reduced is what I'm trying to show. At the level 1 variables, I have the original 0s and 1s because I'm not doing cluster mean centering. If I had done cluster mean centering, I would still start with these columns, but then I would do the cluster mean centering in Excel so that I can get the differences. Okay, are you with me so far? So at level 1, I'm showing all 3 possibilities for kinds of kids. At level 2, I'm only going to show a contrast between 2 categories at a time for the contextual effects. And this plot is designed for paid versus reduced, holding constant free. The formula is tedious but not impossible. So I'll zoom back out again. Try to zoom back out again. Nope, hang on. There we go. So as you can see, the pattern is intercept plus slope times variable plus slope times variable plus slope times variable. So just making sure that these are all tied to the right spots when you're doing Excel, and that you've included all the interaction terms, for instance. So like this one's a squared term, this is a cross-level interaction, it would multiply both variables. Then I took these predicted values and I transposed them into a more organized table. But rather than pasting them, I entered those as cell references too. So like this one is tied to whatever that came up with. That way, if I have to adjust my formulas, all the values will stay with it. So then I built, these are different kinds of schools, and then I have what happened for each different type of kid. So then that led to, come back, there we go, my happy little plot here. So these lines aren't linear. They're broken. Coincidence or consequence? Consequence of what? Yes, a line plot is maybe not the best choice for these kind of data, but sue me. I like them the best. Yeah, like, and actually, to me, this is effective at showing sort of like the break is where the slope changes. And so these are 2 different fixed effects in the model that we're creating. We have paid versus reduced as the first contrast that was in the model, and then reduced versus free as the second. And it looks like the hit that you take in transferring from paid to reduced is not as large as the hit you take from going from reduced to free. Eyeballing it. I've got the coefficients. Yeah. So a difference of 5.8 versus 4.7 for the reference school. Then, are these lines parallel or non-parallel? Yeah, they're non-parallel. Coincidence or consequence? This is for shadowing your presentations, by the way. Because you're going to make a picture and you're going to be like, does this look right? And these are the questions you should ask yourself. So these are non-parallel lines. They are getting closer together. That is as it should be because we have a cross-level interaction. However, that cross-level interaction is operating only on the first chunk. So after reduced, those lines are parallel. In this model, we only have a main effect of the second contrast that differentiates free and reduced. The pattern of the interaction is such that the more students with reduced lunch in your school, for students who pay for lunch, the worse your school does. And even more so as you move up the variable of reduced lunch. So this is the spread of the lines is sort of growing as we move down the colors. And then the implication of this is that there's not as much of a difference due to school composition in reduced. So the gap is narrowed essentially in schools that have more poor kids. But someone might be, well, what about free versus reduced? Does that matter? Well, let's spin it another way. And we'll talk about holding constant reduced, what is the contribution of free? So same idea, but now I have to plan my values a little more carefully. So I want to talk about the difference in free as a function of free, percent free. So I've created schools where I've got 10%, 20%, 30%, 40%. In order for that to hold proportion reduced constant, I have to add a constant to that, like 10%. So this column is dictated by the proportion free plus a constant for reduced to hold it at 10%. Otherwise, it works out to be the same. And so now if I'm holding reduced constant and I look at the difference in contextual effects as a function of proportion free, it looks to be like a little bit narrower, not as much. And then if I hold paid constant and I vary reduced versus free, they're right on top of each other. So to me, this indicates that it is really the discounted lunch idea. It's not the kind of discount that matters at the contextual level, because you can argue there's not much here in terms of further hit for your composition. So this is the tricky part, is trying to figure out what is logically possible across your variables and the way that you've centered them. And this is something that we can help with, by the way, if you get stuck and you're like, here's my model, how would you suggest plotting it? These are all just using fixed effects, by the way. That is on purpose. The idea is that we're not trying to make inferences about particular schools in the data set by adding in their random effects. We're trying to say, for a school that looks like this, here's what would happen. So hypothetical based on fixed effects only is the idea. Okay, that was the model that I ended up plotting. But we're not done with the handout yet because I've got one more model to follow. Let me see what other questions I wanted to ask. Model implied between R square. Yeah, looks like we picked up, relative to the model where we didn't separate out reduced versus free, we have picked up another 6% of the slope variance unexpectedly, and a little bit of the residual, and we made the intercept a little bit worse. Random slope, I tried that for the new term. Here's what Stata said.
Perfect fit
Nope.
or broken?
Broken. Okay, the Stata was
Well,
like,
it was one of the two.
this means here are what the numbers are on the last iteration where I quit. Not that it converged, I just hit some maximum and I gave up. So if you see dots like this, your model is broken and you cannot consider anything from it.
Question.
Mm-hmm.
Is there something in Stata like there is in R where you could, it probably potentially give it more iterations to try before it gives up?
There is.
I'm guessing that you know it off the top.
Yeah,
of your
I'd
head.
have to
Just
look
in
at what it
general,
is.
is there?
Yeah, if you look in their documentation, they have suggestions for how to deal with difficult models in terms of adding start values or
Okay.
like,
Cool.
yeah, you can always fuss with those things. Anytime that it is, how do I want to say this? Anytime that you are adding, like, make this run longer, I would not worry about that as a choice. Like, go ahead and try it. But if you're like, oh, make it so it converges at this value that's easier to hit than the one it's defaulting to, that's where you get nervous.
That's more challenging.
Well, the way I look at it is that those values were chosen for reasons, and as someone who does not have a math stat background or a computer programming background,
Programming only has so many.
yeah,
significant
I'm going to
places.
stay in my lane and decide to use the defaults that the programmers who knew better specified. Now, if you're someone like my husband, you know, who rolls their own and has patents for their algorithms, and you want to change your criteria and you know what you're doing, Godspeed, but that's not me. So here's what's interesting to me. If you are a naive user of a software package, even you would be like, does this look right to you to have dots in my output? And this is what SAS looks like too, by the way, it's dots. But then you get down to Elmer. Here's a solution. It seems fine. This is not zero. These correlations are not on a boundary. It's all okay. But then in the output, you get this little message here. Optimizer no-lop T-wrap convergence code. Okay, yo. Boundary singular fit C-help is singular. I think that means broken.
Yes. I looked up that code. It means broken.
And whoever decided that this was an acceptable way to convey that message deserves a special place in the Human Factors Bad Use Hall of Fame. Is singular, I know that word.
Yes.
I know singular, that means redundant. That's what it translates to, let's put it that way. I'm skipping about 10 layers of technical explanation, but it means redundant. But my point is that this makes me very nervous because it looks like I should be able to trust these results, and then it's saying that I don't. So in these situations, this is where I'd probably go to multiple software packages and look for converging evidence. Things will converge in SAS that don't in Stata, and vice versa. And R seems to be the most problematic, but I have my biases. Either way, though, assuming that you trust these results, a likelihood ratio test indicates that we would not want to keep this random slope. And by the way, notice that there is now degrees of freedom 3 for the test of that new random slope, because we already had a random intercept and 1 random slope. We're adding a second random slope, which entails 3 new terms. That new random slope's variance and its covariance with the other stuff that was already there. So that is non-significant. So even if the model we're okay, it's not helping to have that random slope in there, so I wouldn't keep it. Here's what SAS says. It says your new variance is 0 to 15 decimal places, and your new random slope is perfectly correlated with your intercept. So SAS is like, nope, I'm not having this either. Interestingly, I wrote a little function that does likelihood ratio tests from proc mixed output, and it's only counting 2 degrees of freedom because it's just saying, nope, that one doesn't count because it's 0. So either way, same conclusion, we don't need it. So, all right. I wanted for completeness to go ahead and try the same pattern of interactions that I did for the other one. However, following on your quiz that Erica walked you through on Tuesday, this term right here, I am allowing the difference between reduced and free to be moderated by the proportion of kids who get free versus reduced at the school level. This is a cross-level interaction that is going to explain what? Note that I'm at the end of its line. Is there anything in it to be explained? In its row? In its level 2 equation, do you see some kind of residual term that it can explain? So where do we got to go find it? Yeah, all the way back to level 1. So this is an example of a cross-level interaction that creates a systematically varying level 1 effect. It's not that it's fixed, that it's the same for all the schools. It's not that it's random, every school gets their own. It's that schools get a different level 1 fixed effect as a function of their status on this contextual variable, but not randomly otherwise. This term varies systematically, not randomly. And I'm okay to do that because I just tried the random slope and it's really not there to the point it caused problems. I also added in the squared term to unsmush it as well. And then I did all the linear combinations and stuff for completeness. And at this point, I'm like, Lisa, stop. Call it done. But I'm me. I'm my own worst enemy. So here's the rest of this. Now, here's some things that are a bit concerning. So I have a coefficient for the new squared term, for instance, at level 2 of 32 with the standard error of 32. I have a squared term for the other one that's a coefficient of 31 with the standard error of 22. So this is making me nervous. Fixed effects don't break models, but I don't think this model can support this many terms that are all related to each other. Because remember what's at the bottom of this? One ordinal predictor of 0, 1, or 2. That's what's at the bottom of all of this. Erica's laughing at me. I know. This stuff gets complicated.
So this is not because of your sample size, it's just because of what you're trying to predict with.
Yeah, I mean, I have a decent sample size at level 2.
Well, I'm not saying it wasn't, but you, because of all your interactions, they could be.
Yeah, I'm trying to pull apart too much is the sense I get. Like these things are all related to, and trying to pull them apart somewhat artificially is causing problems. I would expect this to be even worse if I only had 20 schools or something. I know some of you have very small sample sizes. This is at least 90 some odd schools. So, question? The evidence is that I'm out of ideas and I need to turn this in.
Time to
And
publish.
well, at some point, like if you can't think of any other reasonable research questions that should be answered, like you just have to decide you're done. And that can be a function of that as a consideration, what reviewers want as a consideration, and also like what your reader can reasonably tolerate. There's a phrase that Patrick Curran coined on Quantitude. I think he called it reader energy. And it's a finite amount of things. Like when you open a paper and sit down and read it, like you may have to come back and finish it, but there's only so much you can process. And so showing them 8 more permutations of something that sort of doesn't help make your point is probably not in your reader's best interest. So pragmatics comes down to it as well.
Is there a thing where you might submit, like, say, 3 articles off of the same study for that purpose?
Yes, but carefully. Those are called LPUs, least publishable units. And that is a practice that some folks would frown upon in the sense of you're just trying to get more papers for your CV. Like you're not
As
trying to do
opposed
more
as opposed
science.
to actually just trying to make it more palatable.
Yes, but done carefully and thoughtfully, it can work. So if you have more results than you feel comfortable fitting in one paper, maybe there's another audience, like a different kind of journal that might care about this too, and you could sort of target them.
Or like subset this
Mhm.
and this.
If you have a bunch of data that you spent a whole lot of time and energy collecting and the models didn't turn out how you wanted, but they're cool models and not everybody knows how to do them in your field, you turn that into a tutorial. That's how I published my master's thesis. It got rejected outright from like 3 different journals. And then I used it as the token analysis in a paper that I actually really like that I wrote as a postdoc. So there's my 3rd paper, right? That's using data that analyses that weren't in my dissertation or my master's thesis or whatever that for a separate purpose. So that would be like, think of ways to make it like different pieces for different reasons, not just like part 1, part 2, part 3 or whatever. But
Yeah.
if the results are not enough to stand on their own, but you feel like you want them out in the world, supplemental materials are good for that. Especially nowadays, journals will let you put anything online. So you can just post like, here's a document that has a whole bunch of other models that I tried, just so you know I tried them. Like that's a reasonable thing. Yeah, but in practice, like yeah, these things aren't really helping, and it's starting to fall apart. So I would say this is enough for this analysis. Effect sizes, stuff. Results section starts here. So yeah, here's all my words. A lot more words than I would potentially put in a paper, but I wanted to be clear for your purposes. And so then we get into reporting this. Yes, and by the way,
Is there standard tabbing that show that this is within your model?
what do you mean?
For your fixed effects, how you're tabbing in?
Oh,
Or is that a personal choice, or is that typically a required?
it is not typically a requirement, but in complex models, I find it useful. So this is like a header.
Right.
So this is like the idea of what this effect I'm talking about is, and then here are the different permutations of it. I feel like that's more effective than trying to shove this information into 3 different lines. And then it shows how like basically the organizational premise is like this fixed effect, and here's the contextual effects that go with it. Here's this fixed effect, and here they are. This is nice to do, but not strictly necessary. This is more for your purposes. But you can't do this kind of notation mapping unless there is a direct equation that goes with it. You can't just throw the symbols in, otherwise they're meaningless. If you wanted to show linear combinations of things as part of this, like this is where you could actually explicitly show, that this is made of this fixed effect plus that fixed effect. I did that in my book, again, mostly pedagogical reasons. Let's see, yeah, so note that I have all the variance components too. Don't forget those in your tables. A lot of folks do for complete reporting. So then words, picture. Mm-hmm. My note would say something like all terms are as defined in equation 2. Something like that. Yeah, so usually you will have more than one equation in the paper and you have to say which one it's tied to. So, yep. All right, any questions on this? Can we really call it done? Like for real this time, I mean it? No, I meant example 4, not the class. Just this 23-page handout. Okay, I'm closing it down.